I'm Anil Kumar. Welcome to my series on vectors. We'll discuss position and velocity in this particular video. I picked up test questions. We have 4 questions in all, right? So we have 4 questions to answer. We'll begin with the concept itself, which is relation between position and velocity vectors. So let's consider that the object is at position A, for example. Let's say this is position A to begin with. We may call this at times as initial position. And let us say that this object is moving in this particular direction with some constant velocity. So this movement is moving with constant velocity. Okay. So after some time, let us assume that the object reaches point B. Correct. So in that case, let's say this is our final point. Okay, let's say final point. Now in vectors, we can actually relate all these things, right? So we say displacement is A to B, right? That is displacement. Now, displacement can be defined in terms of all these things which we have defined here. If I am saying that the initial position is given by vector A and time taken to reach point B is t or any multiple b and beyond, and if it is going with the velocity v, then the displacement will be represented by initial position plus change in position, right? Do you see that? So here we have this as our initial position, and this is change in position. Clear? So if you add the change in the position, you know the displacement. Well, I wrote AB, but I could just write it in general, R as a vector in a straight line, right? So that is to generalize. Now here, T actually belongs to any real numbers, and that will give us all the points in between and beyond, since we say if it is moving in between and beyond, right? So at any instance of time now, we can find different positions. Do you get the idea? So that is how we will relate positions with velocity. Perfect. Now there are some other related terms in general. Here we have written the displacement, but we could also write velocity as in terms of displacement, right? We could also say velocity is equal to displacement over time. When I'm writing R, I'm actually, let me rewrite R, which is the position actually. Okay, so now displacement and position are two different things. Displacement is change of position, okay? So, and velocity, we can say average velocity when we consider displacement divided by time. So the position will be given by this vector equation, right? Displacement, you have to consider two values, in this case A and B. The difference between their values will give us a displacement, right? So we get velocity as displacement over time. And let me insert here, displacement is change in position. Clear? So displacement is going to be change in position, right? Now in vectors, velocity has two components. It has a magnitude, which is the speed, and the direction. Perfect? Okay. Now with that simple concept, we'll actually take 4 questions. So our interest is to understand how to solve these questions. But I hope concept is clear. Question number 1 here is, an object travels at a constant speed from point P to Q. If PQ is 24I minus 15J in meters, and the time is 3 seconds, find its velocity and speed, right? So, using this equation, we can say velocity is equal to displacement over time. In this case, PQ is the displacement from P to Q, as we were explaining from A to B. So it is 24I minus 15J divided by the time taken, which is 3, or we could write this as 8I minus 5J. Is that clear? Where I and J are the unit vectors in X and Y directions, correct? Standard. So that is part A. Now part B of this is to find the speed. So speed actually is the magnitude of velocity. So in this case, the magnitude will be 8 square plus 5 square square root. Correct? So that's how you could find it. So we get 64 plus 25 square root. So 5, 9 and 2, 89 square root. Correct? So that is going to be the speed. Now it's important to include the units, and we have meters and seconds. So we're talking about meters per second. So those are the speed and velocity units. Is that clear? So 81 is kind of 9.5. So we're just leaving like this. 9 is 81. So we could write this as approximately 9.5 meters per second, right? So I'm not using calculator, just estimating. Since it is very much between 90 and 100, right? I mean, 81 and 90, right? 80 and 100, I mean. So 9 times 9 is 81, so we just estimate. Okay. Let's take the second question now, which is write the velocity of a particle traveling southwest at 10 meters per second in the form of AI plus BJ. So southwest means what? Southwest means this is south, right? That is north. This is east. That is west. So when we are saying that the velocity of the particle traveling southwest at 10 meters per second. So that means this, right? Now this 10 meters per second. We have to write in the form AI plus BJ. That basically means that we need to resolve this into the two components, correct? Angle being 45 degrees, correct? Now, I will be negative since it is pointing in this direction, and the magnitude will be cosine 45, and for B, it will be 10 times sine 45, correct? So we can write both these components. So we can say the component along the x-axis, which is A now for us, is going to be 10 cos of 45 degrees, right? So, and B is going to be 10 sine 45 degrees. Now in this case, both are negative, right? So let me write both as negative. As you can see, I and J are unit vectors. I is a unit vector along this axis, x-axis, and J is along y, right? So these are opposite to those vectors. So when we place it here, we'll put minus, and so I'm placing minus. Is that clear to us? Right. So as you know, cos 45 degrees basically is a right angle triangle. Sides are 1, square root 2, 1, 1. So we have 1 over square root 2. So A basically is minus 10 over square root 2. And B is also minus 10 over square root 2. Is it clear? So we could write like this as our answer. Now this could be also rationalized by 2. So you get, we'll do this work here now, minus 10 times square root 2 over 2, or we'll write this as dividing by 2 is 5 minus 5 square root 2. Right? Similarly, this will be also minus 5 square root 2. Clear? So we get the component, the velocity as equal to minus 5 square root 2I unit vector minus 5 square root 2j. Clear? So that is how we are going to resolve it. So I hope all the steps are clear. So that is for 45 degrees. Now let's take the next example. Now the question is, a particle is traveling on a bearing of 135 degrees at 5 meters per second. Write the velocity of this particle in the form of AI plus bj meters per second. So when we say bearing angle, it basically means from north, right? So from north, 135 degrees means 90 plus what? 90 plus 45. So, well, again we got 45 degrees. Okay, so the direction is something like this. We are given this as 5 meters per second. We need to resolve this into two components, which are these two components, right? So that is I, this is j. I is positive, j is negative this time, correct? Moving downwards. So you can easily do this, since basically this angle is again 45 degrees, correct? So you can write this 5 velocity of 5 meters per second in this form as what? So it is 5 over square root 2. Now the I component is positive, right? Minus 5 over square root 2 j, correct? So I'm leaving it as such for now. So that is in the form of AI plus pj. Very easy, right? Now as a practice question, let's change the question. So we now have velocity as equals to, let's say some value 12 meters per second, and bearing angle of, let's say 300, okay, degrees, right? So if we have that situation, how are you going to do it? So I'd like you to pause the video, solve this question, and then look into my suggestions, right? Okay, so we are always measuring bearing angle from north, moving clockwise. So 300 will take us to this position, right? 60 less, right? So then 360, and finally we come in the quadrant 2. Right, so that is it. So in this particular case, the I component is going to be negative, and so we can write A as equal to 12, and this angle total is 300, right? So this angle here is, this is 60 degrees, right? 360 minus 300. So we came to 30 degrees, right? So the I component here will be negative. So A is negative 12 cos of 30 degrees. And B will be the going upwards positive 12 sine of 30 degrees. Clear? To find the sine and cosine, you can always use your special triangle where the position is 1, 2 and square root 3. And so you could also write this as, or use calculator, okay? So for, this is 60 degrees. So for 30 degrees, we are looking from this side. Cos is square root 3 over 2. So we get minus 12 times square root 3 over 2, which basically will be minus 6 square root 3. And as far as b is concerned, the value will be 2 times sine 30 is half, will be 6. And therefore, I can write this vector as equal to, so a for us will be minus 6 square root 3I plus 6j. Is that clear to you? So that is how you could do it. So with this, you understand clearly how to resolve velocity into its components and then rewrite. Perfect. Now here, after knowing all this, we have a good question for you. Now this is a thinking question. At 12 noon, a Coast Guard at point O observes a ship with position vector 1410 kilometers relative to its position. The ship is moving at a steady speed of 12 kilometers per hour at a bearing of 300 degrees. Find the time when the ship is due north of the Coast Guard. So I'd like you to now pause the video, answer this question, and then look into my suggestions, right? Okay, so let's try to understand the situation here. So what we have is everything in the positive quadrant, okay. So we are not making it to the scale, but we're saying that we'll make it approximate. So the ship is moving in the direction which is bearing of 300. So from here, if you see 300, will be just as we did last time, right? So we'll be kind of like this, right? So it is, this is 30 degrees, right? 270 plus 30 gives you 300, right? So that is the direction in which the ship is moving. But what we are given here is that the initial position is given to us, and which is 1410. So it is moving parallel to this direction. You understand? And this position here is given to us as, we can write position vector 1410, where this is origin. Is that clear to you? Now, the ship is moving at a steady speed of 12 kilometers per hour at the bearing of 300. We have sketched all this. Find the time when the ship is due north of Coast Guard. So due north of Coast Guard means we want to find this point, right? Find the time when it is at this point. So we need to find this time. I hope the question is absolutely clear now, right? So you can still pause the video and now do the question. Perfect. Okay. So here, let's try to figure out the velocity or the position vector basically. So we can actually find the position vector. So position will be initial position plus time times velocity, as we wrote initially, right? So we can say R is equal to the initial position of 1410 plus t times the velocity, which is given to us as 12 kilometers per hour at a bearing of 300, correct? So now you understand we did this just now. Let's redo, right? Okay, so then we'll fill this up and then probably we'll get our time and then the solution, correct? So we need to convert 12 kilometers per hour at a bearing of 300. So let's write this vector. Okay, so we'll write this in the form of AI, because we need to write this, right, in the form of AI plus BJ. That's kind of important to us, right? So let's do this. Okay. So we have 12 kilometers. The I component will be cosine of 30 degrees, but negative, right? So we can write velocity as equal to 12 cos of 30 degrees, right? So that is the 30 degrees. Minus sign because it's acting in this direction. I, correct? Plus upwards we have sine of 30 degrees minus, 12 sine of 30 degrees, correct? Okay. So this factor is square root 3 over 2 I, and this is half, right? So it is 12 times half. Or you could write this as minus 6 square root 3 I plus 6. Get it? So that becomes your V. So I'm going to place this value right there now. Is that clear to you? So we have this as minus 6 square root 3 comma 6. So that is why we did earlier a few questions. It helped us to understand the strategy, right? So that becomes your position. Perfect. So we wrote the velocity in terms of I and j components. Now we have a plot here, right? So it is x and y where displacement is clearly seen, right? Okay. Now the question is, find the time when ship is due north. Now when ship is due north at this position, then what happens? Then the x value becomes 0, right? So we say, this is very important to understand, right? So when ship is due north, in that case, what happens? In that case, the x value, which is 14 minus 6 square root 3t, that should be equal to 0. Do you see that? Because the position, I could actually write r also like this. It is 14 minus 6 square root 3t, comma, 10 plus 60. Do you see that? So that is the vector, correct? So that should be 0. So from here, we can find the time. So we can get the time t as equal to 14 over 6 square root 3. Does make sense to you, right? So that is how we can get time, and the units will be hours. So now let's finally use calculator. So we have 14 divided by, within bracket, let me write 6 square root 3. Okay, and that is equal to, in decimals, 1.347. So 1 hours, 1.5 hour, you can say. Okay, so 0.34. So we can say, we can convert this. So we have time as equal to 1 hour and 0.34 times 60. So 0.347 times 60 equals to 21 minutes. Let's say 21 minutes. Is it clear? So that is how we could actually solve this. So we found this 21 minutes by multiplying 0.347 by 60, correct? Which is 21. So that is how we are going to solve this question. Does it make sense to you? Now there could be extension to this question. Now tell me, what will this signify at t equal to, let me write this number, which is 14 over 6 square root 3. What will the y component signify? What will, let's say we have written this in the form of a plus bi, ai plus bj. So in that case, what will b signify? Can you tell me that? What will 10 plus 6t signify? So that is a question for you now, okay? Anyway, so what we have learned here is that this concept of splitting velocity into its components really help us to solve many questions. This is one of the examples. Feel free to explore, and I'll provide you with links where we'll do more kinematics, which will give you good insight to this concept. Right, so that's it for now. I hope it helps. You may subscribe to my videos and keep posting questions. Thank you and all the best.